So in this last example, we're going to be combining all of our knowledge of the equations and of the graphs of exponential functions in order to match equations to graphs. So the first thing we can look at is increasing versus decreasing. We can see the graphs A and B are both increasing, meaning that the B value of the equation must be greater than 1. The only equations that match that would be II and IV. In II we have a B of 3, and in IV, we have a B of 4. Once we've narrowed it down a little bit more, we can look at the y-intercepts. Based on the equation, II should have a y-intercept of 4, and graph B has a y-intercept of 4, so those will match with each other. So by process of elimination, IV should match with A, but we'll just double check the y-intercept to be sure. And yes, A does have a y-intercept of 2, as the equation says it should. So A would pair with IV. The other two graphs, C and D, those are both decreasing exponential functions, which means that B must be less than 1. And we can see that both I and III do have B values of less than 1. Looking at the y-intercepts, the equation says we should have a y-intercept of 3, which we have on graph C. And again, by process of elimination, D should pair with III, but just double checking against the y-intercept, the equation says 4, and the graph does have a y-intercept of 4, so those two match.